Hey guys, here's a video for you about transformations of exponential and logarithmic functions. Our learning goal is that you will be able to apply transformations to graph exponential and log functions. Imagine that. Okay, so on your notes, I've provided you a general table that summarizes the transformations. Now we've done transformations with pretty much every other function we've used in this class, so hopefully these are not new to you in any way. Okay, if we add a value k at the end of the function, then we're moving it either up or down. Likewise, if we add or subtract a number to the x within the function, then we're moving it either right or left. So you can see what it looks like when things move up or down, or notice for when we're moving right and left, we're subtracting from the x or adding to the x that's in the exponent. You've also seen vertical stretches or compressions where we have a number that is in front of the function. Here it's outside of and it's not raised to the exponent. We also have horizontal stretches and compressions where we're multiplying the x inside the function by the number. So here, like 2 to the 3x is a horizontal compression. And then finally, we also have reflections either across the x-axis or the y-axis. Okay? You guys have seen a lot of those before, so I'm not going to give a whole lot of time to that. And likewise, we have the same thing for log functions. We can move a log function up or down by subtracting a number to the end. We can move it left or right by subtracting a number inside the log. We're subtracting it to the x. We could stretch it or compress it vertically by putting a number in front of the log, or we could stretch or compress horizontally by putting a number in front of the x. And finally, we could reflect it. But aside from just saying all that real quick, let's actually do some to help you make some sense of it. Okay, so let's do a few examples. In this first example, our function is 2 to the power of x plus 2. Okay, now let's start by graphing the parent function. The parent function is 2 to the x, since our base is 2. Okay, one important thing to note is that it's going to have the point 0, 1. This is a point that is common to all exponential functions because anything to the 0 power is 1. So you can pretty much always count on that point being a basis for where you draw your rest of your function. Alright, because it's 2 to the x, it's going to be doubling with each time that we move to the left or right. So my next point would be at a y value of 2, then 4, and then 8. Going back the other way, I'd be dividing by 2, so I would have a half. The asymptote for the exponential function is the x-axis, or y equals 0. This is true for pretty much all exponential functions before you transform them. So then I can trace the general shape of the graph. There we go. There's our parent function. Now let's look at how we're transforming it. The x plus 2 indicates that we're moving it 2 to the left. Okay, so let's do that. I'll just move each point on the graph 2 to the left. There you go. Alright, the asymptote did not move. We moved it only to the left or right, so the asymptote is still on the x-axis. Therefore, I can just draw the general shape of my function like that. Okay, not too bad. Okay, let's analyze it to find some of the important details. The y-intercept you can pull off of the graph as 0, 4. In case you ever can't tell what it is, or are looking for it without actually graphing it, don't forget that you can also plug in an x value of 0 to figure out the y-intercept. So 2 to the 0 plus 2, well that's 2 squared, and that's 4, which gets us the 4 that we have in the y-intercept. The asymptote is, whoops, I have that wrong. This should be y equals 0 because it didn't move anywhere. Okay, there we go. Fixed it. Alright, then the domain is negative infinity to infinity, like all exponential functions. The range, because we only have it in the positive side of y, is 0 to infinity. Okay? Not too bad on that one? Okay, so let's move on to another. Here's example 2. F of x equals 3 times 2 to the x plus 1. Our parent function is still the 2 to the x. That's the base on our function. Alright, the 3 is a vertical stretch, so we're going to multiply the y coordinates by 3, and the plus 1, we move it up 1. Okay, we'll start by graphing the parent function again. I'll start with my point 0, 1, and multiply by 2 for each point that I go forward from there. So 2, 4, and 8. And going back the other way, I have a half. Okay, so the asymptote, as always, is the x-axis, and so I'll draw the function. Okay, there's our parent function. Hope you're able to keep up with that. Alright, let's do the transformations. I'll start by transforming the y-intercept, which is at 0, 1. The vertical stretch means that I multiply the y-coordinate by 3. So the y-coordinate was 1, now it would be 3. Then I'll move it up 1 because we translated it up 1. That would give me a new y-intercept of 0, 4. Let's do the transformation to the other points. If I take the next point, which is 1, 2, multiplying the y-coordinate, which is 2, by 3 gives me 6. Then adding another 1 would give me the coordinate 1, 7. Okay? If I transform the next point, the y-coordinate is 4. Multiply by 3, I'm at 12. I'm way off the graph. Okay, so let's move on. And let me transform the 1/2, the negative 1 comma 1/2. I'll erase some of that to get some room. Okay? If I multiply the y-coordinate by 3, that would give me 1.5. Then add another 1, and it's 2.5. So I have negative 1 comma 2.5. What about the asymptote? Well, it's moved up 1, so my asymptote now is y equals 1. Okay, since I have those basic points, let me just draw the general shape of the function. Okay, for when you're doing transformations, transform just 3 points, one on each side of the y-intercept. That'll let you get the general shape of the graph without having to plot too many points. Okay, lastly, let's get the domain and range. The domain, just like all exponential functions, is negative infinity to infinity. None of our transformations changed that. The range, we moved the whole function up 1, including the asymptote, so that means my range is going to be 1 to infinity. Okay, so let's graph one more. Here, my function is negative log of x minus 1. So the parent function is y equals log of x, where it's understood to have a base of 10. Okay, let's draw the parent function. That's the inverse of y equals 10 to the x. So that means that the x's and y's are switched from 10 to the x. So my asymptote then is going to be the y-axis instead. And instead of a coordinate of 0, 1, I'll have a coordinate of 1, 0. Because with the 10 to the x, we're multiplying by 10 each time, my next point will be at 10, 1, because now we're multiplying the x's by 10 instead of the y's. Going the other direction, my other point would be 1/10, negative 1. You could test this by just actually figuring out what value would give you a negative 1 for the log. Okay, so that gives me my general function, which I put in a different color so you could see it better. Alright, so now let's look at the transformations. The negative in front of the log reflects it over the x-axis. Then the minus 1, which is happening to x, moves it to the right by 1. Okay, so let's start by moving the intercept. When I reflect it, it doesn't move anywhere because it's already on the axis. So then I'll just move it to the right 1. So therefore, I would have the coordinate 2, 0. if I transform the coordinate 10, 1, I would move it to the other side of the x-axis, reflecting it, and then move it to the right 1. So it'd be 11, negative 1, which is just barely off of our graph. Likewise, I could move the other one, the 1/10, negative 1, up to positive 1, and then move it to the right 1. What about our asymptote? Because we transformed our function to the right by 1, then it also moved right 1. That gives me enough information to draw the general shape of the graph. Alright, so y-intercept? There isn't one, because a log function doesn't cross the y-axis. It might be possible if we had moved it to the left, but we didn't. Alright, the asymptote, which began as x equals 0, is now x equals 1 because we moved it to the right. The domain, because our asymptote is at 1, is 1 to infinity, and the range is negative infinity to infinity. Notice that's flipped from what the exponential function was. Okay, so hope that all made sense to you. I want to just make one final note that when you're graphing these exponential and log functions, just graph 3 accurate points in the asymptote and just capture the general shape. You don't have to plot every single point that could be on that graph. And likewise, use the calculator to help you plot them. I showed you all the details of how the points were transformed, but I am definitely okay with you putting it into y equals and getting a table to know what points to plot, just to make it a little easier for you. The main thing is knowing how to interpret the transformations and also what the asymptote and domain and range are. Okay, so happy graphing, and I'll see you guys later.